Hello students, good evening to all of you. So here in this lecture I am going to derive the equations of rotational motion, and as you already studied the equations of motion in the linear motion there, so उसी तरह से आज हम rotational motion में भी equations of motion derive करेंगे. So we will start from the first equation. Like आप इसे linear motion के साथ compare करके भी देख सकते हैं. वहाँ पर जो पहला इक्वेशन था दैट वाज b इज इक्वल टू यू प्लस ए टी, बट इन रोटेशनल मोशन द इक्वेशन जो हमें डिराइव करना है वो कुछ इस तरह से रहेगा, दैट इज ओमेगा इज इक्वल टू ओमेगा नॉट प्लस एसलेशन की जगह अल्फा एंड टी की जगह टी. सो दिस इज अवर फर्स्ट इक्वेशन ऑफ मोशन इन दैट रोटेशनल मैकेनिक्स. एंड यहाँ पर वी आर सपोजिंग दैट वी हैव अ रिजिड बॉडी. सो फर्स्ट वी कंसिडर दैट लेट वी हैव अ rigid body, and that rigid body is basically having some uniform acceleration alpha. So हमारे पास यहाँ पर एक rigid body है and जो कि uniform angular acceleration alpha के साथ है, rotate कर रहा है about some given axis there. So we know that that alpha is basically d omega by dt, angular velocity, rate of change of angular velocity with respect to time. So from here we can easily calculate or write that dw is equal to alpha dt there. स्टूडेंट्स यहाँ हमें पहले फर्स्ट इक्वेशन को डिराइव करना है. सो वी हैव द रिलेशन दैट डी डब्ल्यू इज इक्वल टू अल्फा डी टी. सो लेट अस कंसीडर दैट एट टी इज इक्वल टू ज़ीरो द initial velocity, that is omega, that is initial angular velocity, is omega naught, and let at t is equal to t, after time t, the angular velocity becomes omega. So these are our two conditions there, and we apply these two conditions on the equation 1 and get the answer after integrating equation 1 with proper limits. So we'll integrate the equation 1, that is d omega is equal to alpha dt there. So omega का जो limits है that is from omega naught to omega, and time is from 0 to t. So d omega का integration रहेगा omega, and our lower limit is omega naught, upper limit is omega, and alpha is a constant angular acceleration. So dt का integration है t, and it is from 0 to t there. So we can put the limits there. It is like omega minus omega naught is equal to alpha t there. So we can write this as omega is equal to omega naught plus alpha t. So students, this is the derivation of first equation in the rotational mechanics there, that is omega is equal to omega naught plus alpha t. We can simply use the integral calculus there and get the answer. So then now we will derive equation second there. जैसा कि आपने लीनियर मैकेनिक्स में देखा है, लाइक वी हैव दैट सेकेंड इक्वेशन एज इन दैट काइनेमेटिक्स s इक्वल टू यू टी प्लस हाफ ए टी स्क्वेयर. So here that displacement is basically in terms of theta, and u means initial velocity. So here it is omega naught t plus half alpha t square. तो यहाँ हमें ये सेकेंड इक्वेशन जो है वो डिराइव करना है. स्टूडेंट्स, एज we know that omega is basically d theta by dt. This is the relation for omega, like rate of change of angular displacement. This is omega. So omega is d theta by dt. So from here we can write d theta is equal to omega dt there. And now we will simply put the value of omega from the equation 1. We know that d theta is equal to omega की जगह हम भर देंगे omega naught plus alpha t, and बाहर है dt. Again we impose the conditions there, our limits there, and let at t is equal to 0 the theta is equal to 0, and after time t, let's suppose theta becomes theta. So we'll integrate this equation there and get the answer, get our equation of motion. So we'll integrate the above equation, that is omega naught dt, मैंने यहाँ multiply कर दिया इसे, and it is alpha t dt there. So its left side में जो integration है d theta का, it is from 0 to theta, and in the right side the integration is from 0 to t, and it is 0 to t there. So d theta का integration रहेगा theta, and it is from 0 to theta, and in the right hand side omega naught dt का integration हो जाएगा t, and our limit is from 0 to t, plus here also we have alpha t dt. So t dt integration is like t square upon 2, and limits are from 0 to small t. So we'll put the limits there and get our equation. This is theta minus 0, lower limit is 0, so it is simply theta. And this is omega naught, again lower limit is 0, upper limit is t, so it is omega naught t plus half alpha t square. So this is our second equation of motion in the rotational uh, kinematics, or in the rotational motion. So this is theta is equal to omega naught t plus अल्फा टी स्क्वायर अपॉन टू देयर, हाफ ए टी स्क्वायर जिसे आप लीनियर मैकेनिक्स में देखते हैं, काइनेमेटिक्स में देखते हैं. So similarly students, we can derive our third equation, and काइनेमेटिक्स में that was like v square minus u square is equal to 2as, और यहाँ पर वो इक्वेशन रहेगी omega square minus omega naught square is equal to 2 alpha theta. So here we will derive this equation using the integration or differentiation there. So we know that like omega is equal to d theta by dt. Students, omega is angular velocity, it is rate of change of displacement. So it is omega is equal to d theta by dt. हम थोड़ा सा एक्सप्रेशन को यहाँ पर अपने अकॉर्डिंगली बनाएंगे, एंड मैथमेटिक्स के करने के बाद we can get this equation. And here this alpha is angular acceleration, and we know that alpha is basically d omega by dt. Angular acceleration is rate of change of angular velocity with respect to time. So we'll use these two results there and get our third equation of motion. So as alpha is equal to d omega by dt. So we multiply this equation with d theta and divide also with d theta, and rearrange these terms like d omega upon d theta, and one is written as d theta upon dt. So this is the expression for alpha. Basically alpha के लिए हमने लिखा d omega by dt and d theta by d theta, because multiply किया, divide उसी term से किया. So mathematically we are correct. So we have alpha is equal to d omega by d theta, और हमने अभी ये d theta और dt को आगे पीछे इस तरह से कुछ किया है. So we have alpha is equal to d omega upon d theta multiplied with, as this d theta by dt is simply omega, so ये इक्वेशन बन जाएगी हमारे पास अल्फा इज इक्वल टू डी ओमेगा बाई डी थीटा इंटू ओमेगा, एंड वी डू द क्रॉस मल्टीप्लिकेशन देयर, वी गेट ओमेगा डी omega. Now again students, we will integrate this equation within proper limits and get our answer. So here let's suppose that at like initially we have theta is equal to 0, and after some time our theta becomes theta, and during that course of time like our omega was initially omega naught, and finally it becomes omega. So we integrate this above equation, that is alpha d theta, and it is from 0 to theta, and it is equal to omega d omega, and it is from omega naught to omega. So alpha is a constant, d theta का integration है theta, and lower limit is 0, upper limit is theta there, and in the right hand side we have like omega d omega as omega square upon 2 there, and limit is from omega naught to omega. So then left hand side में बन जाएगा alpha theta after putting the limits, and in the right hand sides upper limit is like omega square upon 2 minus lower limit is like omega naught square upon 2. So we can simplify this, 2 हम दूसरी तरफ ले जाएंगे, so it is simply omega square minus omega naught square is equal to 2 alpha theta. So that is our third equation in the rotational motion. So इस तरह से आप इन तीनों equations को जो है वो derive कर सकते हैं. So we started from the first equation of motion, and that was simply v is equal to u plus at, but in the rotational mechanics it is omega is equal to omega naught plus alpha t, and then second one is theta is equal to omega naught t plus half alpha t square, and then finally we have third equation, that is omega square minus omega naught square is equal to alpha theta. So I just hope आपको ये derivation समझ आया होगा. With that, thank you very much.